Okay, dear student, let us see what is there in this question. What is the charge on an electron antineutrino and during what process is an electron antineutrino produced? Okay, so what is happening here is, first of all, let me tell you about the processes in which it does happen. So first of all, it is only in the case of beta plus emission or beta negative emission. We have to see two reactions here. So what is happening at in the nucleus here, let me show you that. So one reaction is this: the neutron is getting converted into proton. Now proton is having a positive charge. So let me explain you this thing later, just a moment. Electron antineutrino plus q value. So now this is the reaction which is taking place inside the nucleus when beta emission is taking place. What is happening? The neutron is converting itself into proton, and obviously one neutron is lost but one proton is created. It means that there is no change in the atomic mass number, and conservation of mass and conservation of charge takes place here. This we are going to study in topic 7.3. So this neutron mass is 1 but the charge is 0. Yeah, so now this is 0 on the left hand side, so it has to be 0 on the right hand side of the reaction also. So plus 1 minus 1, that will become equal to 0. That is why the electron will be produced with the negative charge, and this is known as electron. Okay, dear student, let us see what is there in this question. What is the charge on an electron antineutrino and during what process is an electron antineutrino produced? Okay, so what is happening here is, first of all, let me tell you about the processes in which it does happen. So first of all, it is only in the case of beta plus emission or beta negative emission. We have to see two reactions here. So what is happening at in the nucleus here, let me show you that. So one reaction is this: the neutron is getting converted into proton. Now proton is having a positive charge. So let me explain you this thing later, just a moment. Electron antineutrino plus q value. So now this is the reaction which is taking place inside the nucleus when beta emission is taking place. What is happening? The neutron is converting itself into proton, and obviously one neutron is lost but one proton is created. It means that there is no change in the atomic mass number, and conservation of mass and conservation of charge takes place here. This we are going to study in topic 7.3. So this neutron mass is 1 but the charge is 0. Yeah, so now this is 0 on the left hand side, so it has to be 0 on the right hand side of the reaction also. So plus 1 minus 1, that will become equal to 0. That is why the electron will be produced with the negative charge, and this is known as electron antineutrino. Now electron antineutrino is always having 0 mass and 0 atomic number. My dear students, there are students those who are confused, like why the mass of electron is taken to be 0, although the mass of electron is actually not 0, isn't it? Because mass of electron is actually 9.110 raised to power minus 31 kg. It is not 0. So how can you say that the mass is taken as 0? Now what I tell you about this is, like, what is the mass of a proton? Mass of a proton is this, minus 27 kgs. It means that mass of a proton is 10,000 times more than the mass of electron. That is why we can just assume that the mass of electron is comparatively 0. We are regarding the mass of proton as 1. So this 1 actually here, it just shows how many hadrons are there. Like hadron means proton and neutron. Again, 7.3, we will be talking about that in details there. So 1 means there is one nucleon, one proton or one neutron. So electron is like mass is really very less, so we can just assume that the mass is 0. That is why we'll take it as 0. Now this is the antineutrino which is produced. Now they're talking about electron antineutrino only. So this is antineutrino, and neutron is now converted into proton. So, first of all, what is the charge? There is no charge on the antineutrino or on neutrino. I would be giving you the other reaction also. Now, the production of electron antineutrino is accompanied in, this is known as beta minus decay. We do not call it electron decay, we call it beta minus decay. Okay, so beta minus during this or this, so clearly the answer will be D in this case. But before we move further, let me tell you about the beta positive decay also, beta plus decay also. What is the reaction that is taking place now? So in beta plus, what is happening? Proton is converted into neutron. Now, proton is converted into neutron, it is accompanied with electron, but because of the conservation of charge, the electron got to have a positive charge on it. Because on the left hand side of the reaction, you have a plus 1 charge here. So, 0 plus 1 will give you plus 1. Plus electron neutrino, not antineutrino. Again, the charge is 0, mass is 0, plus Q. What is Q? Q is heat. So that will be liberated here. Now, these are the two reactions which are taking place inside the nucleus for the beta positive and beta negative. So this is beta minus and this is beta plus. So in beta plus, what is happening is electron neutrino is coming. Electron neutrino is produced. So this is another reaction which is producing beta plus and this was producing beta minus. So both of the reactions are on your screen. Everything is now completely explained for beta emissions. Okay, so this is how we do this question. So the answer will be D. So my dear students, thanks for joining. This is Professor Varun. Please subscribe to the YouTube channel. All the best. Bye. In this question, which of the following lists the particles emitted during radioactive decay in order of increasing ionizing power? It's very, very important that we know what ionizing power is. So what is the increasing order? Although the increasing order is given by A, I can clearly see it, gamma, beta and alpha, but we must understand like what is the ionizing power. So first of all, let us understand about the alpha. Now, what is alpha? Alpha is actually the helium atom when the electrons have been removed from it. So you can say that alpha is helium 2 plus. The proton number of proton is 2, so atomic number is 2 and the mass number is 4. So the students, those who are opting for chemistry, they know what I am doing here, but the students, those who do not have the chemistry, please be careful here. 4 is the atomic mass number, 2 is the atomic number, that is number of protons, and 2 plus because the electrons have been taken away. So overall it is only the nucleus of helium, so 2 protons and 2 neutrons. So this is what is the alpha particle. Now this alpha particle is comparatively bigger in size and it is heavier comparative to beta, which is just an electron, and gamma, which is actually not a particle, which is electromagnetic wave. So alpha is regarded to be a very heavy molecule. Now what happens is, let us say there is this gas there and the alpha particles are trying to pass through the gas. Like let us say these are the gas molecules and alpha particle is trying to pass through it. So alpha is going like this or going like this. So when this alpha moves past the gas, what happens is it strikes the electrons of the gas molecules. Now the mass of electron is really very less, which is like 9.110 raised to power minus 31 kgs, and the mass of one proton is given by 1.6610 per minus 27 kgs. It means that it is already 10,000 times heavier than electron. But the nucleus is having 4 such particles. The mass of proton is approximately equal to neutron. We can say that the mass of alpha is 40,000 times more than the electron. 40,000 times more. Just try to imagine, like you're talking about 1 kg of a block somewhere and there is a truck which is 40,000 kgs. Now that truck is colliding with 1 kg stone or 1 kg's weight. What will happen to that 1 kg? So ideally speaking, according to the conservation of linear momentum principle that we have done in topic 2, this electron will actually fly away with double the velocity of alpha particle. So if alpha is coming at some velocity, electron will shoot away with approximately double the velocity, if we are not giving credit to the theory of relativity, by the way. So it's just an ideal condition. Don't go into 100% details. So overall, the electron is taken away from by alpha. So electrons are taken away from the atom. Clearly the gas is getting ionized, and the gas molecules are now becoming positively charged. So this is called ionization. And alpha obviously will be having the best of the ionization properties, because it is bigger in size, heavier in mass, and all that. Now comparatively we can talk about beta. So beta is just another electron. So electron is colliding with electron. It's like snooker balls, or like when we play pool there. So what is happening is one ball is hitting another ball. So obviously the ionization power of the electron will be far more lesser, and according to the books it is written as it is 100 times lesser than alpha, according to the books. So this is 100 times lesser, the ionizing power. In the case of gamma, I can say gamma is just an electromagnetic wave. So you can say that, yeah, it is also a particle, but that particle is the packet of energy, which is known as photon, given by Einstein, and the theory by Planck, obviously. So this photon can be regarded as a particle, but although it is actually not a particle, so it is just acting like energy. So ionization power of gamma is even lesser, isn't it? But the penetration powers are completely different. And about the numeric, this this ionizing power of gamma is 10,000 times lesser than alpha. 10,000 times lesser. Now similarly we can talk about the penetration power also. Gamma's penetration power is the maximum, beta is the second one, and alpha is minimum. And again the ratios is the same. So that is why the increasing order of ionizing power will be given by gamma, beta, and alpha, but the penetration power will be given by alpha, beta, and gamma. So gamma is having the maximum penetration power, then beta, and then alpha. I think this much of the explanation should be very good. But if you need more explanation, do watch other videos. Also, you can mention that in comment section. So this is Professor Varun. Thanks for joining. Please subscribe to the YouTube channel. You will find all of the features there, and that will be highly beneficial for your preparation of your examination. So all the best. Bye. In this question, a nucleus of phosphorus decays into the silicon with the emission of particle X and particle Y. What are X and Y? A very beautiful question, and you are going to get so many of these kind of questions. So it's very important for us. In such a question, what we have to see is that whenever there is an alpha decay, the atomic mass number will reduce by 4 and atomic number will reduce by 2. Okay. Now, if I talk about beta minus, the atomic mass number does not change. It remains the same. But the new atomic number is, it increases by 1 in beta minus. Very, very important. If it is beta minus, atomic number will increase. Now, if it is beta positive, again, the mass number does not change, but the atomic number reduces by 1. You have to remember this thing. It's not given in the data booklet, nowhere, anywhere. You just have to think on it. Like if it is a negative electron is given, atomic number increases, positive, atomic number reduces. Now, in this case, we can clearly see that the atomic number is decreasing by 1, but the mass number is constant. So mass number is constant, atomic number is decreasing. It means you're talking about beta positive. So X should be beta positive. It means that electron with plus 1, it is also known as positron. So the positron is released here. And whenever a positron is released, we know that there is a neutrino that is actually produced. So a neutrino will be produced, electron neutrino, not antineutrino. So it will be neutrino, and yes, so positron will be produced. So answer will be D. So this is how we do this question. There are two reactions that I have already given you in some of the other questions, and the reaction inside the nucleus, this is what is actually happening there. Plus electron neutrino and plus some heat will be produced. So this is the reaction that is actually taking place inside the nucleus. Okay. There is another reaction, but I'm not giving it here because it will unnecessarily create the confusion. You can go to the other video, like I think question number 3 something. You can see that and you would be finding the same. Okay, my dear student, let us see what is the answer given in the mark scheme now. According to me, the answer is D. And yes, the answer is given as D. So, my dear student, this is Professor Varun. Thanks for joining. Please subscribe the YouTube channel and all the best. All the best. Bye. There in this question, the half-life of a radioactive element is 5 days. A freshly prepared sample contains 128 gram of this element. After how many days will there be 16 gram of the element left behind in the sample? So overall, there is a very simple concept here that when one half life is over, like 5 days is over, the amount, whatever it is, the units can be in gram, it can be in kgs, it can be number of particles, it can be moles, whatever it is. So whatever unit it is, but so whatever value it is, it will become half in one half life. So accordingly, you can find like how many half lives will be there. So you can see, but there is a simple formula also to be used in such kind of cases. So it is given by n divided by n naught is equal to half raised to power number of half life. So it is t divided by t half. So this kind of expression makes it really very easy to solve. Otherwise, you can definitely go for like keep on multiplying half until you get 16. You can count the number of halves that you are multiplying. Actually the same thing, but we prefer using this. So number of nuclei should be 16 now, and we started with 128. So half raised to power number of half lives, and so 16 divided by 121. So what is it? I'm not remembering the table now. So 4, yeah. So 4 fours are 16, 4 threes are 12, 4 twos are 8. Now to 16, I think 8. Yeah. So yes. So 1 by 8. So clearly this is 1 by 8. So this value t divided by t half should come out to be equal to 3, because this can be written as 1 by 2 raised to power 3. So t divided by t half is equal to 3 and t half is 5. It means that in 15 days you would be finding this situation. So your answer will be 15. My dear students, although I know there are students those who are doing like half multiply by half multiply by half multiply by half. You can do that. It's a good method, but this method I believe is more usable because many a times you would be getting confused sometime. So this is a very important formula you can take with yourself. Yeah, this is how we do it. Let us see the mark scheme and what is the answer for us. The answer is C. And yes, the answer is C. So this is how we do this question. Dear students, thanks for joining here. Please subscribe to the YouTube channel and do share the video with all your friends. All the best. Bye. Okay, dear students, let us see what is there in this question. A pure sample of nuclide A and a pure sample of nuclide B have the same activity at t is equal to 0. Nuclide A has a half-life of t and nuclide B has a half-life of 2t. So to start with, they have the same activity at t is equal to 0. And what is the activity of A divided by activity of B when t is equal to 40? So, my dear student, in this kind of question, first of all, we must understand what do you actually mean by activity and what are the formulas with which we can work around. So, um, the activity is written like this. So, activity A is written by negative dn by dt. You might be remembering in the case of radioactive decay law, we studied that negative dn by dt is equal to lambda n, or directly proportional to n. And then it was becoming dn by dt, so it was lambda into n. And accordingly, when we integrated it, we got n is equal to n naught e raised to power negative lambda t, and we called it the radioactive decay law, where lambda is the decay constant, n naught is the initial number, n is the number of nuclei left, and lambda is decay constant. Yeah, this is a bit of theory that I'm giving here for the radioactivity. But this factor, negative dn by dt, it is taken to be A, and A is the activity of the radioactive sample. So activity means like which radioactive sample is having more speed. So if somebody is having more speed of disintegration, we just say that the activity is really very high. It's like that. So A is the activity. Eventually, like this comes out to be equal to lambda n, isn't it? Like this negative dn by dt is equal to lambda n. So I've taken lambda n. N can be written as n naught e, that will be written here. This value can be written as the initial activity. Be very careful. I have just derived another formula for you. So activity is also having the exponential variation, absolutely same as that of the number of nuclei and all that. So this formula is actually given many at many places, but they are not talking about the activity, and so students are generally confused like what is activity and how, what are the formulas which we have to talk about. Although activity is a completely different thing from number of nuclei, but they have the same variation, they have the same formulas, and everything is the same. So this activity is given by this formula. Now the question is activity of this and this. So another formula is A naught is equal to lambda n naught, A is equal to lambda n. This is how they are related with the number of nuclei in the sample. Now t raised to power 4. So we have to substitute this value here, but we do not want to do that, isn't it? Yeah, because that will be unnecessarily bringing in the exponential factor. We do not have those in option. There is another formula. Be very careful. Even this formula is not given anywhere. So n divided by n naught is equal to half raised to power t divided by t half. So I've given you this formula in some of the other videos earlier. So it can be used, this kind of formula can be used to find what is the number of nuclei left in the sample when you started with n naught number of nuclei, and t half is the half life, t is the total time period that you are talking about. Same formula can be used here. So A is equal to A naught is equal to half raised to power t divided by t half. Same formula. This is what we are going to use in this question now. So this much is for the background information, and this we are going to see now. A activity can be written as A naught, this divided by t divided by t half. Now, clearly the half-life is given for both of the samples, time is given for both of the samples. We have to find the activity. Okay, so this much is written, so you people can note up to this by pausing the video, and I'm just deleting this part now. Yes, so our formula that we are going to use is this. So activity of A will be given by A naught. I'm writing A naught because it is same in both of the cases. Half raised to power 40 is the total time we were talking about, and for this the half life is t. So 40 divided by t, it becomes 4. So A naught divided by 2 raised to power 4. 2 raised to power 4 is 16. So A naught divided by 16 is the answer. Similarly, we will find A2, and that is A naught raised half raised to power, the time is 40, half life is 2t. So it becomes A naught divided by 2 raised to power square, isn't it? Raised to power 2. So it becomes A naught divided by 4. Now, A1 by A2, we want to have the ratio of this. So A1 divided by A2. It will be A naught by 16, and this will be reciprocal, and we will multiply the reciprocal here. A naught and A naught cancelled out. This becomes 1 by 4. So I believe you must be understanding what I am doing it here. Students might be having some problem in the algebra in that part, but if you really concentrate on this thing like what I have done, that should not be any problem to you. This is what I'm doing, and then I'm just reciprocal it, and I will multiply these two. So this is what I'm getting, and clearly the answer is D for this question. So it's a very deep question, very important question, and I think in the topic of radioactivity, this is the one of the most difficult question that you will ever get. So if you are good with this question, you are good with almost all of the questions of the radioactivity. So this question becomes very important. And remember the background information that I have given to you. Just try to check what are the formulas given in the data booklet. Other formulas you have to remember. So this is how we do this thing. This is Professor Varun. Please subscribe to the YouTube channel. All the best. Bye. Let us see what is there in this question. Four of the energy states of an atom are shown. The transition between any two states is possible. What is the shortest wavelength of the radiation that can be emitted from these four states? On the surface, looks like really very difficult question, and students would be confused like how to do this. But do not worry about this. There is a method of doing it. So that you can understand like how to find the shortest wavelength and the longest wavelength. First of all, we must remember that the formula for the energy of a photon is h nu. At nu is the frequency, which can also be written as hc by wavelength lambda. So if the frequency is high, energy is high. If frequency is lower, energy is lower. Similarly, if wavelength is now indirectly proportional to energy, so if wavelength is shorter, energy is higher. If wavelength is bigger, the energy is lesser. Now they're talking about the shortest wavelength. So shortest wavelength means the maximum amount of energy possible. So maximum energy, obviously the biggest transition has to take place because we want to talk about the maximum amount of energy change. So that is from E1 to E4 clearly. So the change in energy should be E4 minus E1. Now the shortest wavelength will be emitted. So he's talking about the emission spectra. So energy should be emitted. So if energy is emitting, it means that electron initially was at higher energy level and now it is actually dropping to the lowest energy level. Only then it will be emitting energy. Otherwise, it will absorb energy and the electron will get excited. So this is de-excitation that is taking place, or relaxation that is taking place. So E4 minus E1. Now, this is the total energy. So total energy, like this is one of the principle of Bohr, that the total energy which is given out by the electron, that will be given out in one packet of energy. It cannot create two packets or three packets. So one packet of energy is given by hc by lambda. Clear? So lambda is shortest. You can write lambda minimum here. We want to find the lambda now. So lambda will be equal to hc divided by E4 minus E1. Do we have that kind of option here? Yes, the A option is clearly written there. So A is the correct option for this question. This is how we do this question. It's a highly conceptual question, no doubt about that. You can think on it, and please watch the video again and again if you do not understand it. So there can be many options, no? Like they can create another question which will say maximum wavelength, minimum frequency, or the maximum frequency. You must know how to answer this question. Okay, my dear students, so this is how we do this question. Let us check the answer from the mark scheme. For me, the answer is A. And yes, the answer is given as A. Okay, dear students, all the best. Bye. Please share the video with all of your friends. Okay, dear students, let us see what is there in this question. What statement about alpha, beta, and gamma radiation is true? Gamma radiation always travel faster than beta particle in vacuum. Which statement is true? A is definitely true. So, okay, I would be explaining you all the options, like why are they wrong and why are they correct. So, first of all, alpha, beta, and gamma. So, alpha is the heaviest, beta is electron, it is lighter than alpha, but gamma is just energy, so it is lightest. So gamma is electromagnetic wave. So because it is electromagnetic wave, it travels with the speed of light, 100%, and nobody can move at a greater speed than the speed of light. Obviously, gamma is the best. Now, the velocity of beta is nearly 99% of c. And in the case of alpha, it is nearly 95%. So 90% or the 95%. So it is lesser. So we can clearly say that gamma radiation always travel faster than beta particles in vacuum, no doubt about that. In air, beta particles produce more ions per unit length traveled than alpha particle. So no, this is the option B is talking about the ionizing power. So in some previous videos we have already seen that alpha, the ionizing power is maximum, then beta, and then gamma. For gamma, it is minimum. So B is wrong. Alpha particles are always emitted when beta particles are emitted. No. When beta is emitted, then there is only beta that is emitted. Alpha is like, they are completely different nuclear reactions. We have already seen those earlier, but anyways, let me write it here. This is uranium, it is converted into thorium. One particular example about this, like this is alpha, like this, helium. Now, this is one of the examples of radioactive decay. Clearly, there is no beta, nothing. In fact, the two protons and two neutrons are just thrown out of the nucleus of uranium. In the case of beta, there is a clear-cut transformation of one proton into neutron or neutron into proton. So those are completely different nuclear reactions. I have already given to you those. Like one of that can be written like this: antineutrino, electron antineutrino plus heat Q, and the another reaction can be written as this. It will be better if you remember these, okay? Like this. So these are the two reactions which take place in the case of beta. This is beta minus, this is beta plus, and so even C is wrong. D, alpha particles are deflected in the same direction as that of beta in a magnetic field. Of course not, because alpha is positively charged here, like alpha is helium nucleus and having 2 plus charge, and beta particle is actually an electron. So beta minus is negative, beta plus is positive. So this is partially correct, because like they have written beta particles. No, beta plus would be deflecting in the same direction. Beta minus will be deflecting in the opposite direction because it is negatively charged. So overall, D will also be like, we can treat it as partially correct and partially incorrect. So D is wrong, and definitely the answer is A. So this is the explanation for all of these things. Along with the ionizing power, we must talk about the penetrating power. So ionizing power is maximum for alpha. In penetrating power, gamma is max. As per the penetration power is concerned, gamma is max, and this is minimum for penetration power. By penetration power, we mean that alpha particle can be stopped with the help of one layer of aluminum foil that you use in your kitchen, isn't it? So that much is enough to stop alpha particle. But gamma, it cannot be stopped. Gamma is not even stopped by 30 centimeter of an iron wall. Gamma radiation can penetrate through 30 centimeter of iron wall. That is why it is really, really very, very dangerous, harmful, and very powerful nuclear radiation. Okay, so this is what I can say here. Okay, dear students, this is Professor Varun. Please subscribe to the YouTube channel. All the best. Bye. Okay, dear students, let us see what is there in this question. Which graph shows the variation of activity with time t of the radioactive nuclide? So in a couple of videos earlier, we have already discussed activity in a great detail. You can watch that also. But in this video also, I would be discussing a bit here. So what is radioactive decay law? So you must be knowing already that n is equal to n naught e raised to power minus lambda t. This is derived from this radioactive decay law, that it is directly like the rate at which the radioactive sample is decaying is directly proportional to the amount of nuclei left in your sample. Obviously that those numbers are reducing, so even the speed is reducing. It's like a child is eating chocolate, isn't it? Like when a big piece of the chocolate is remaining in the refrigerator, so you are eating chocolate bigger pieces. But when, let us say, with time the chocolate is reducing, now even your eating speed is reducing, isn't it? So accordingly, here also their eating speed is reducing just like that. Anyways, so this can be written as negative dn by dt, which is equal to lambda n. On integrating it, we get the formula n is equal to n naught e raised to power minus lambda t, which I have already written here. This is known as radioactive decay law. But this is not about the activity. This is about number of nuclei, number of masses, like what is the mass of that, it be in grams or be in kgs, be in number of moles. So this formula is used from that point of view. But we want to talk about the activity. What is activity? Now, activity A is defined as negative dN by dt. So this very factor is written as capital A now, and this is equal to lambda n. So this is lambda n. This value of n can be substituted here. It becomes lambda n naught e raised to power minus lambda t, which can be written as a naught e raised to power minus lambda t, and this is a. Clearly, we have created another function. We have just derived that the formula for the activity with respect to time t. And you can see that even this and also the radioactive decay law, both of these laws are having exponential variation. So we can just see it here. So D should be the correct answer. Why? Because it will be touching the y-axis at some certain point, because this is going to be the initial point, that is A naught, and it is moving according to the exponential behavior, and it is going to create an asymptote here. So D is clearly the correct answer. In this case, y-axis is not touched. In this case, x-axis is touched. And in this case, both of them are touched. So all the three are wrong, and D is the correct answer. So this is how we do this question. This is about the variation of activity, and I have shown you that this activity is also exponential. So my students, this is how we do this question. This is Professor Varun. Please subscribe to the YouTube channel, participate in Kahoot live tests, as also you can join the YouTube channel if you want to access the paper 2 questions. So this everything, all the services are being provided by me on the YouTube. Please subscribe to it. All the best. Bye. So in this question, let's see. A simple model of an atom has 3 energy levels. The differences between the adjacent energy levels are shown. What are the 2 smallest frequencies in the emission spectrum of this atom? Again, I told you, like in couple of questions earlier, that there will be some questions which will be talking about the minimum frequency or the maximum frequency also. So there it is. So we want to have the smallest frequency. So energy is given by h nu. So smallest frequency means that you are concerned with the smallest energy. Smallest energy means smallest energy gap. So smallest energy gap can be found in this and this smallest frequency, because there is a third possibility also, that electron is jumping from top, from the third level to the first level, but again the gap of energy will be really very big, so the frequency will be higher for that. But we want to have the 2 smallest, so this is going to be the smallest, then this, and then the third one, but we want to find the last 2. So one is this, another is this. So in the case of first, the energy is given by 6.63 10 raised to power minus 19. That will be now equated with hc by lambda, but we want to find the frequency, so it will be h nu. And clearly the frequency in the first case can be taken to be divided by Planck's constant, in which it is also 6.636 10 raised to power minus 34. This can be just taken over, like it's approximately 1 only, and this will be 10 raised to power 34 minus 19. So uh, how much is this now? 34 minus 19 is 4, 5, 10, 15. So it is approximately equal to 10 to the power 15, and that even positive. So either C or D is the answer. Now we are going for the second case. So second case energy is 13.3 into 10 raised to power minus 19. By using the same formulation, we would be dividing it by 6.636 10 raised to power minus 34. So this is going to give you the same value, 10 raised to power 15. And what about this, 2 or 3? So it's approximately 2, isn't it? Like we can clearly say it, 6 2s are 12. So it's approximately 2, and clearly the answer will be C. So this is how we do this question, my dear student. And let us see the mark scheme also to verify the answer in this case. And yes, the answer is clearly C. So this is how we do this question. This is Professor Varun. Please subscribe to the YouTube channel for all the other benefits. You can clearly, you can go to the YouTube channel, see what are the things that I am providing you with. Okay. All the best. Please share the video with your friends. Bye. Dear students, let us see what is there in this question. Which statement about atomic spectra is not true? So he's talking about the Bohr's model of the atomic structure, which is applicable on hydrogen, and like metals like this. So there are shells and electrons are moving up and down. They provide the evidence for discrete energy levels in the atoms. Yes, indeed, no problem at all. Like definitely because of this model only, from the atomic spectra that we get, emission spectra and the absorption spectra, we jump to this conclusion that there must be energy states. Now, emission absorption lines of the equal frequency correspond to the transition between the same two energy level. Absolutely correct. So, if you are falling from the third to one, or you're going from one to three, the energy will be the same. But the only thing is, either in one case it will be absorption spectra, in another case it will be emission spectra, but the frequency will be same, energy will be same. Now, see, absorption line arise when electrons gain energy. Absolutely correct. When the electrons gain energy, at that time they jump and they go to the excited state, and that is why absorption spectrum is created. Obviously, the answer is D now. So, emission line always correspond to the visible part of the electromagnetic spectrum. No, my dear friend, no, it's not like that. So there is a concept here. So there, so in chemistry, might be students have studied that Lyman series, Balmer, Lyman, Balmer, Paschen, bracket, and fun like that. So what is happening is, like, let us say there is energy level one. Just a moment. This is first energy level, second energy level, third energy level, fourth, fifth, like that. So when somebody is like coming to the first energy level, wherever is the electron jumping from, but it is jumping into the first energy level. These are known as Lyman series, and the energy produced is UV rays, ultraviolet. Now, when some electron is jumping into the second shell, they are producing visible light. This is known as Balmer series, and visible light is produced. And when the electrons are jumping into the third or into the fourth or fifth or the longer one, everywhere now only and only infrared is produced. Clear? So it's just a piece of information which is an additional piece of information for you, because IB is asking you questions about visible light. Might be they would be asking you question about UVs or infra. This is what is happening. Now I'm going to give you the names also. This is known as Lyman series. This is known as Balmer, Lyman, Balmer, Paschen. Not actually remembering everything. Lyman, Balmer, Paschen, bracket fund. Whatever way you pronounce it. So these are the five series, and these are the radiations which are produced in this. So this is how we do this question, my dear student, and answer for our question will be D. So this is Professor Varun. Please subscribe to the YouTube channel. Please join the YouTube channel, because you would be getting so many other things. You are going to access the paper 2 questions, and you would be participating in the Kahoot test also, if you are a subscriber to the YouTube channel. Okay, then, all the best. Bye. Friends, let us see what is there in this question. Three particles are produced when a nuclide undergoes beta positive decay. What are the two of these particles? Fine. So we have to write the complete information here, first of all. So as I have already told you, that in beta positive decays, the atomic number decreases by one. Okay. And what is the reaction taking place in the beta decay? Beta positive, I think proton is going to disintegrate itself or convert itself into neutron. So it will be a positron here and an electron neutrino plus heat. So beta plus is produced in this reaction. So technically this is happening inside the nucleus. Proton is converting itself into the neutron. So number of nucleons are not reducing. One proton is dying, but one neutron is born. It means that atomic number, mass number is not going to change. So 23, so mass number is going to be 23. That we are sure about. And what about the atomic number? Obviously, proton is constituting in the atomic number. Now, one proton is reducing. It means that atomic number will reduce by 1. So, atomic number reduced by 1, so it will become 11. So, sodium will be created, no doubt about that. Now, he's talking about the neutrino and the antineutrino. So, whether it is neutrino or antineutrino, this is what they're asking. So in beta positive, it is accompanied by a neutrino. So electron neutrino will be there and answer will be A. So A is the correct answer because neutrino is produced. Overall, the reaction will look like this. This is converting itself into sodium. Mass number will remain the same. Along with it, a beta positive decay is there, and electron neutrino is produced, and some heat is produced. So on the surface, it looks like magnesium is converting itself into sodium. And if this reaction is given there, students are not able to see through this question that actually a proton is getting converted into neutron. So in this question, we would be learning it in 7.3 in coming topic, that in these kind of nuclear reactions, charge is always conserved, mass is always conserved. So another thing, you can clearly see 1 is equal to 1 plus 0, and this is always 0 and 0. So 1 plus 0 is equal to 1, and here 1 is equal to 0 plus 1 plus 0. Okay, this is known as Sodi-Fazan rule, but that is not actually in your syllabus. So you might not be knowing about it, but just you already know this thing already, but you don't know the name. So I have given you the name. It is Sodi-Fazan rule. So this is how we do this question, my dear student. This is Professor Varun. Please subscribe to the YouTube channel. Please join the YouTube channel if you want to access paper 2 questions. All the best. Bye. Okay, dear students, let us see what is there in this question. The diagram below shows 4 energy levels for the atoms of a gas. The diagram is drawn to scale. The wavelengths of the photons emitted by the energy transition are shown below. Lambda 1, lambda 2, 3, 4. What are the wavelengths of the spectral lines emitted by the gas in order of decreasing frequency? Okay, so bit confusing. They're talking about the wavelength also and the frequency also, but don't worry. So lambda 1, lambda 2, lambda 3 is just for the sake of telling like which transition are you talking about. But we have to arrange these energies into the order of decreasing frequency. It means decreasing energy. So decreasing frequency means that the energy gap should be decreasing. So what is the biggest energy gap you see here? Lambda 4. So lambda 4 is biggest, and then lambda 1 clearly, and then lambda 2, and then lambda 3. So lambda 4, lambda 1, lambda 2, lambda 3. B is the answer for this question. So it's completely straightforward. Don't get confused about it. The concept that I have used here, what is it? That the energy which is liberated is, it can be written as E is equal to h nu, or it can be written as hc by lambda. So uh, the more is the frequency, more is the energy. So it says that we want to have decreasing order of frequency. So more frequency to lesser frequency means more energy to lesser energy. More energy is clearly available here because it's talking about lambda 4. The gap, more is the gap, more is the energy. Simple. And this is how we do this question. I think the explanation that I have given you here is enough to understand this. Even then, if you feel any problem, like you are not able to understand something, please do mention that in the comment section. Okay, I think like energy gap is giving you the total change in energy, and that is directly related with the frequency, and it is decreasing order of frequency means decreasing order of energy. And we have just seen the diagram, which energy is big, which energy is lesser, arranged it accordingly. So the answer is B. Let us see the mark scheme, if the answer is B in the mark scheme or not. And clearly the answer is given as B. So this is how we do this question, my dear student. This is Professor Varun. All the best. Bye. Dear students, let us see what is there in this question now. Photons of energy 2.3 eV are incident on a low pressure vapor. The energy levels of the atoms in the vapor are shown below. So all the energy levels have been shown here. What energy transition will occur when a photon is absorbed by the vapor? It means that when the energy is absorbed by the electron. So if electron is absorbing energy, it will go up. So obviously we will just assume that first of all the electron is here in the ground state. Okay, only then it will absorb the energy. If it is in the excited state, it is not going to absorb anymore. So it's like that only. Like once it has absorbed, it has to come down to absorb it again. So obviously it is at the ground state now. So energy is negative 3.9 and 2.3 is absorbed. So what is the total energy now? So negative 3.9 plus 2.3. So I can say 2.3 minus 3.9. So calculator is in front of me. 2.9, 2.3, sorry. 2.3 minus 3.9, and the answer is negative 1.6. So clearly it is going to this. So this electron will jump into this shell, which we can call it like first excited state, second. So this is second excited state, or you can say it is n is equal to 1 to 3, or n is equal to 3. So it is moving from n is equal to 1 to n is equal to 3. So from the answers we can say 3.9 to this. So clearly A will be the correct answer, and this is how we do it. My dear students, this is also given here. You see, like it is going from negative 1.6 to negative 3.9. Well, the amount of energy will be 2.3 only, but it will not be absorbed in that case. In that case, 2.3 electron volt energy will be released by the atom, and that photon will be created by the atom, but it will not be absorbed. So clearly our answer is A for this, and let us verify from the mark scheme whether the answer is A or not. And clearly yes, the answer is A. So my dear student, this is how we do it. This is Professor Varun. Thanks for joining. All the best. Bye. Okay.